Hey guys, today we're going to be talking about angles and the different relationships that they have. So what I'm going to need you to do to get prepared for today's lesson is to either get out your journal, get out a piece of paper, and a writing utensil because we're going to take some notes. The first thing that we're going to talk about, which should not sound new to you, but if it does, that's okay, are supplementary angles. Supplementary angles are two angles that form a straight line which sums to 180 degrees. So what I need for you to write on your paper is the word supplementary angles, and then you're going to write our definition, which is two angles that sum to 180 degrees. Remember, sum means add up to. And if you look at our picture right here, you have angle A and angle B, and they show you that you have A plus B to equal 180 degrees. What you guys are going to see this kind of problem look like is you would be given two different angles, and each angle would have an expression of its angle measure. Now, because our first angle right here and our second angle right here do form this straight line, we know that their two angle measures combined will be 180. So you'll take the first expression and you'll add it to the second expression, and you're going to set it equal to 180. Remember from our previous unit earlier this year in equations, you can combine like terms. So when you look and you see 6x and a positive 4x, because remember the sign in front sticks with the term, you know that that will combine to make 10x. Next, you see positive 1 and positive 9. That combines to make a positive 10. And all of that will still equal 180. From here, now we're just going to solve our equation. And remember, we use inverse operations. So I'm going to draw my line to show the two different sides of my equation. And I know that my goal is to isolate this variable right here. And the first thing I need to do is move my constants, which is this positive 10 right here. And to cancel out a positive 10, I will subtract 10. And remember, if you do it to one side, you have to do it to the other. Your positive 10 and your negative 10 create a zero pair. And all that's left on your left-hand side of the equation is your positive 10x, and that will equal 170. Now I still have not isolated x, and I have 10 of them, so that's actually multiplication. So the inverse of that will be to divide by 10, and if I do it to one side, I'm going to do it to the other. I know 10 divided by 10 makes 1, so I am left with just 1x on the left-hand side, and 170 divided by 10 gives you 17. So this is the kind of problem you guys are going to be expected to do. Our next angle type are complementary angles. These are two angles that sum to 90 degrees. This means they form a right angle. So again, guys, remember that you need to be writing down your vocabulary word and the definition. If you look at our picture right here, you see 30 degrees and you see 60 degrees. Remember this little right angle right there tells me that that's 90 degrees. And just like the last one, you guys are going to be expected to write an equation and then solve it using these different kinds of angle measures. So I'm going to draw a pair of complementary angles, and as I draw that, please make sure you write this down in your notes. Notice I put the box to indicate that that will sum to 90 degrees. And the top one will have an expression of 5x plus 7. And then the second one will be negative 2x minus 3. And so notice, because I know they form this right angle right here, I can take my first expression and my second expression, and I can combine them to equal 90. So I'll have 5x plus 7, and then a negative 2x minus 3, and that will equal 90. I'm going to draw my line to show the different sides of my equation. And just like last time, I see that I have like terms that I can combine. I have a positive 5x and a negative 2x. That will combine to make a positive 3x. And then I have a positive 7 and a negative 3. This will combine to make positive 4. So all I've done on the left-hand side of my equation is simplify it by combining like terms, and my right-hand side will still equal 90. Just like our previous example, I need to get rid of my constant, which is this positive 4 right here, and I can do that by creating a zero pair using inverse operations by subtracting 4 on both sides. My positive 4 and my negative 4 will cancel out, and that 3x is going to come down because it does not go away. 90 minus 4 is 86. And now I have 3 times x equals 86, but I only want 1x. So I'm going to divide both sides by 3. So I know 3 divided by 3 simplifies to 1. So I'm just left with 1x on the left-hand side, and that will equal whatever 86 divided by 3 is. So because I do not have my handy-dandy calculator like you guys do, I'm going to come over here and do this by hand with long division. I know that I can fit 2 groups of 3 inside of 8, and so I will take away 6. That leaves me 2, and I'll bring my 6 down. I can fit 8 groups of 3 into 26, which gives me 24. That leaves me with 2. And now I don't have anything left to bring down, so what I need to do is put my decimal here, also up there as well, add a 0, and bring it all the way down. So I get 20 at the bottom now, and I can fit 6 groups of 3 into 20, so I take away 18, which still leaves me with 2. And if you guys remember long division, you know that that 0 will come all the way down, and I still have a 20. So what's really going to happen is I'm going to get a repeating decimal for my answer. So I'm going to go ahead and round that to the nearest tenths place. So if I look at 28.666 and it goes on and on, my tenths place is the first number behind the decimal. In order to round to that place value, I look at the number right behind it. Because 6 is greater than 5, greater than or equal to 5, I'm going to round my tenths place up to give me a value of 28.7. So x will equal 28.7. And generally, you guys are going to have prettier numbers and things that end in either 0.5 or whole numbers. Our next one is the triangle sum theorem. It is exactly what it sounds like. Our triangle sum theorem tells us that all 3 angles in a triangle will add up to 180 degrees. So that means if angle B in our picture right here is 100 degrees, and angle A, let's say, is 60 degrees, then C has to be 20 degrees because they have to all add up to 180. And what that would look like for you guys, you would be given a picture. Notice I showed that the lines on both the left and the right hand side of the triangles are the same. So our bottom angle will be 3x, the other angle will also be 3x, and our top angle will be 4x. Using our triangle sum theorem, I know that 3x plus 3x plus 4x will have to equal 180. When I draw my line, on the left-hand side, I see that I have like terms that I can combine. 3x, 3x, and 4x combines to make 10x, and that will still equal 180 because all I did on my left-hand side was simplify by combining like terms. Right now, x is being multiplied by 10, and I want to isolate it by using inverse operations of dividing by 10. 10 divided by 10 simplifies to 1, so I am left with 1x on the left-hand side, and 180 divided by 10 is 18. So we get that x will equal 18 right here. Our last review is what we call vertical angles. And for those of you who don't remember what these are formed when we have intersecting lines. So the first thing we want to say is these are formed by intersecting lines. And notice on the picture, they kind of form like a V for vertical. So I would have this angle right here, which is a vertical angle to this one. So our stars are vertical angles. And we also have another pair of smiley faces, which are also going to be vertical angles. What's important about vertical angles is that vertical angles are congruent. Oops. And remember, congruent means exactly the same. So over here in our picture, if star is 30 degrees, then the other star also has to be 30 degrees. And using our knowledge of supplementary angles, remember, which are two angles that form a straight line and will add up to 180 degrees, I know that smiley face has to be 150 degrees because these form a straight line. Well, since smiley face and the other smiley face are also vertical angles, this will also be 150 degrees. And what this would look like for you guys is you would have a pair of intersecting lines, and you would be given that 2x minus 1 would equal 4x minus 7. Because these two expressions are formed by these vertical lines and vertical angles, I know that they have to be congruent, which means their angle measure has to be exactly the same. So what I can do is I can say, all right, well, let's say this is star and this is another star. They have to be the same. So 2x minus 1 has to equal 4x minus 7. And now I have variables on both sides of my equation. So what I need to do is move all my variables to one side and then my constants to the other. So I'm going to move the 2x, and I can create a zero pair with positive 2x by subtracting 2x. And if I do it to one side, I need to do it to the other. 2x minus 2x leaves me with 0, and I'm left with a negative 1 on my left-hand side. 4x minus 2x is a positive 2x, and I still have this minus 7. So I've now gotten all my variables on one side, but my constants are not on the other. So I need to move the negative 7 to the other side. And I can move that by adding 7 to both sides. Negative 1 and a positive 7 makes a positive 6. I'm left with 2x, and then negative 7 and positive 7 create a zero pair. The last thing that I need to do is divide both sides by 2 in order to isolate x. So I get that x is equal to 3. Notice how it's written 3 is equal to x, but I can also write that as x is equal to 3. Those are the same things. So that's kind of a review of all the different angles that you guys have seen and what you'll be expected to do with them. And now we're actually going to take a look at the new stuff to 8th grade. So we're going to take a second and explore. And what I want for you to do is I want for you to make a T-chart. And I want you to list out some things that you notice and some things that you wonder as we go through this. If you're curious after this and you wanted to go play around with the simulation yourself, I have included the link in the post on your Google Classroom. If you have not had time to make your Notice and Wonder T-chart, please pause this video right now and go ahead and list out all the things that you noticed about the simulation and all the things that you wonder. So I'm going to give you a second to pause and finish your work before we move on. All right, you guys, let's take a look at your notices and wonders, and I'm going to read you mine. I noticed that there were 2 lines that were kind of sliced by another one. I saw vertical angles because I saw V's. And I also saw supplementary angles because they were angles that combined to make a line. I also noticed that as it moved, a lot of the angles still had the same measure even though I was moving the lines. I wondered if they're always going to be the same measure. And then I wondered if some of them have specific names. So we're actually going to move on and address some of these wonders. Here we go. So using what we did and what we just looked at, I'm going to write an angle measure. And I'm going to say this is 140 degrees. What I want for you to do is I want for you to draw your 2 lines cut by our 3rd line, and I want you to predict what you think the measure of each angle is going to be. So pause the video, draw the 3 lines, take a moment to predict, and then when you're ready, unpause to see if your answers were correct. All right, you guys, let's see how y'all did. So using relationships that we already know, I know that I have vertical angles right here. So that will make this 140 degrees. And then I see that I have supplementary angles right here, which will make this measure 40 degrees. Then using vertical angles, this will also be 40 degrees. I'm hoping that we were able to at least get those 4. So now let's check the other ones on the other lines. This angle measure is 140 degrees. This one is 40. We have another 140 degrees and another 40. Pat yourself on the back if you guys got it all right. That's awesome. So now that we've predicted, let's actually go look at it. So what we're actually looking at is 2 parallel lines. So that would be lines L and lines M that are cut by a transversal. A transversal is just a line that cuts across other lines. So for us, this is going to be line N. So we have parallel line right here, parallel line right here, and then we have our transversal, which is line N. When we have 2 parallel lines that are cut across by a transversal, it kind of looks like it forms a sandwich. And so we have angles, we have 8 different angles that are created. We have angle 1, 2, 3, 4, 5, 6, 7, and 8. In our sandwich, we have the inside angles, and that's what we call the interior angles. And if you think of the word interior, think of kind of like interior design, it's on the inside. So these are interior angles. And then on the outside, we have exterior angles. So our interior angles would be angles 3, 4, 5, and 6. And our exterior angles will be 1, 2, 7, and 8. And if you guys think back to my wonder about if these have specific names, they actually do. They have specific names and very specific angle relationships, which we are going to move right on into. The first one that we are going to look at is called corresponding angles. So what I want for you to do is I want for you to draw your 2 parallel lines cut by your transversal and label your angles 1, 2, 3, 4, 5, 6, 7, and 8 like so. What corresponding angles are, and you should remember this word when you looked at similar figures and transformations, corresponding means the same location in a different space. So for our purposes today in looking at angles, what I want for you to think of when you see corresponding angles is I want for you to think of they are angles that are in the same seat at a different table. So for example, if we're thinking of this as kind of like a table of 4 and another table of 4, then angle 1 right here is sitting in the same seat as angle 5. So angle 1 and angle 5 are corresponding. At this moment, I want you to pause the video and I want you to attempt to label the other 3 pairs of corresponding angles. All right, I hope that you guys got angle 2 and angle 6, angle 3 and angle 7, and then angle 4 and angle 8. So now that we know what corresponding angles are, let's talk about their actual relationship. Corresponding angles, and this is very important, and you guys will look at this in Algebra 1 and Geometry. Corresponding angles are congruent. And remember, congruent means the exact same. So let's write this up here. Congruent means the same. So what that means for our purposes is that if angle 1 is 130 degrees, then so is angle 5. If angle 2 is 50 degrees, then so is angle 6 because they're corresponding. So please make sure that you guys have written down all of these things that we have so far before we move on to the next angle relationship. All right, our next one, we have alternate interior angles. So again, you guys guessed it, I want you to draw your 2 parallel lines cut by your transversal and label them 1, 2, 3, 4, 5, 6, 7, and 8. Now, because we are looking exclusively at interior angles, that means it's going to be on the inside of the 2 parallel lines. We're not going to be looking at 1, 2, 7, and 8. An alternate means opposite. So alternate interior angles are interior, so on the inside, interior angles that are on opposite sides of the transversal. So our first example would be angle 3, and the angle that's on the opposite side of our transversal, which remember is line N, would be angle 6. It wouldn't be angle 8 because angle 8 is in the exterior. So angle 3 and angle 6 are alternate interior angles, and so would angle 4 and angle 5. And the cool thing about alternate interior angles is that they are also congruent. So this is very important. So if angle 3 is 45 degrees, so would angle 6. And if angle 4 was 135 degrees, then angle 5 would have to be the same because they are congruent. Take a moment to pause the video if you need to finish any of your writing before we move on to the next one. Now, we're looking at exterior angles. So draw your two parallel lines, draw your transversal, and label. Because we're looking at exterior, we'll be looking at the outside. So we will not be looking at angle 3s, 4s, 5s, or 6s. And just like last time, alternate meant opposite. So these are angle pairs in the exterior and the outside that are on opposite sides of the transversal. So angle 1 is in the exterior, and angle 8 is on the opposite side of of our transversal line N, also in the exterior. So that would be angle 1 and angle 8, and then also angle 2 and angle 7. Alternate exterior angles are also congruent, which means the same. So angle 1 and angle 8 would have the same measure, and angle 2 and angle 7 would have the same measure. Last but very not least, we have same side. Okay, so instead of looking at opposites like we did with the alternate interior and alternate exterior, we're now looking at the same side, interior angles. So draw your lines and label your angles so that we can get started. Because we're only looking at the interior, we'll only be looking at 3, 4, 5, and 6. And same side is exactly what it sounds like. These are two angles both on the interior, so two angles in the interior that are on the same side as the transversal. So we have angle 3, and the angle that's along the same side as our transversal would be 5. They're both on that left-hand side of the transversal. So we have angle 3 and angle 5. And then we have angle 4 and angle 6. Now, unlike all the other angle relationships that we've seen, same side interior angles are supplementary. And if you don't remember from earlier, supplementary means they sum to 180 degrees. So if angle 4 is 160 degrees, then angle 6 would have to be 20 degrees because these two values would need to add up to 180. Now that we've looked at all of them, I want you to take out the piece of paper that was provided to you, and we're going to work through this together. Our first question is, what is the measure of angle 1? Notice that they form a straight line, which means that they're supplementary and they add up to 180. So I will take 180 and subtract 55 to get 125 degrees. So I know that the measure of angle 1 is 125 degrees. I can use vertical angles to know that 2 is 55 degrees. For 3, 4, and 5, our measure of angle 3. Guys, remember our angle relationships, and I see that 140 degrees and angle 3 are sitting in the same seat but at a different table, which means they are corresponding angles, and corresponding angles are congruent. So angle 3 needs to be 140 degrees. To find angle 4, I see that the 140 degree angle and angle 4 form a straight line, which means they're supplementary. And supplementary means that they would need to add up to 180. So I can take 180, subtract away the 140 to get the leftover 40 degrees. That would be angle 4. Number 5 asks us for the sum of the measures of angles 3 and 5. Well, I don't know the measure of angle 5 right now, but because angle 3 and angle 5 are intersecting lines and they form vertical angles, angle 5 also would be 140 degrees because vertical angles are congruent, which means that they would sum to 280 degrees. Lines A and B are parallel. That's going to be important. Lines A, B, and C intersect at point X. Lines B and D intersect at point Y. Lines B and C intersect at point Z. And then we're given this diagram. We want to know the measure of angle 6. 120 degrees and angle 6 form a straight line, which means they're supplementary. So they sum to 180 degrees. So angle 6 will be 60 degrees. To find the measure of angle 7, and I know this one can be a little complicated to see, we have parallel line 1 with parallel line 2 that's cut by this transversal. And notice that 45 degrees right here and angle 7 are sitting at the same seat in a different table, which means they're corresponding angles and they are congruent. So angle 7 will also be 45 degrees. For number 8, they tried to trick us, but if you guys see, and I'm going to do it a different color, this forms a big triangle. So what I'm going to do is I'm going to draw it on the outside so it's easier to see. We have angle 8, we have 45 degrees, and we have 60 degrees. If you recall from the earlier part of the lesson, all three angles in a triangle always add up to 180. So what I'm actually going to do is I'm going to take away this angle 8, and I'm going to replace it with x because I don't know the angle measure. But I know that 45 plus 60 plus x will need to be 180 degrees. I can combine 45 and 60 to make 105 plus x is equal to 180. And now all I need to do is subtract 105 from both sides to get that x is equal to 75 degrees. So angle 8 is equal to 75 degrees. All right, now we're going to do some always true, sometimes false, never true with some explanations. So for number 9, we are given that angle 1 is always greater or is greater than angle 3. And we know that that is never true because those form vertical angles, and vertical angles are always congruent. And so now they give us that the measure of angle 3 plus the measure of angle 4 has to be 180 degrees. They form a straight line, so that will be always true because they are supplementary. And remember, supplementary angles form a straight line and sum to 180 degrees. Oops. Lastly, now we have the measure of angle 4 and the measure of angle 2 is less than 180. Well, if we look at our picture, probably, but let's say I make this our bigger angle and that one. They can definitely sum to more than 180. So that is only going to be sometimes true. Because angle 4 and angle 2 could be obtuse sometimes. And remember, obtuse means that they're greater than 90 degrees. All right, guys, last thing that we're going to be doing together. So now we are looking at a pair of parallel lines that is cut by a transversal. And we want to look at angle 1 and angle 7. And it says that they are congruent because this little symbol right here, that means congruent. I know that those angles are alternate exterior angles, and alternate exterior angles are always congruent. So this will always be true because alternate exterior angles are congruent. Our next example has us looking at angle 1 and angle 6. The measure of angle 1 plus the measure of angle 6 is greater than 180 degrees. Well, angle 6 and angle 2 are corresponding, which means they have to be the same. So for sake of us guessing and checking and just kind of hypothesizing, let's say angle 1 is 150 degrees. That would make angle 2 30 degrees, which would make angle 6 30 degrees because corresponding angles are congruent. 150 plus 30 is equal to 180. It is not greater than. And because this angle 6 will always need to be the same as its corresponding angles, and angle 1 and angle 2 form a straight line, this is never going to be true. And we can say with our explanation that it will never be true because angle 6 has to be supplementary. Remember, forming 180 degrees. To angle 1. Last but not least, we have the measure of angle 3 plus the measure of angle 6 is equal to 180. And I know that this is always, always, always true because those two angles are same side interior angles, which will always be supplementary. So we will say that they are same side interior angles and they are supplementary. All right, guys, that is the end of our lesson, but I do want to explain to you guys what you will be doing for the rest of class. You guys are going to be working on this in groups. Notice there's multiple parallel lines with multiple angle relationships. You are given this information down here that angle 1 is 84 degrees, angle 12 is 48 degrees, and angle 22 is 90 degrees. You know that your numbered streets are parallel, so you're going to be using your parallel angle relationships. Harrison is parallel to Taft, and Hayes is parallel to McKinley. So you guys are going to work with an elbow partner or a group of 3 to find all of the angle values for angle 1 through angle 32, and you'll record those on the back of the paper with your justification of why. Once you're finished with your classwork, you guys will have homework if you don't finish it in class, but it is only 4 questions. And as always, if you guys need anything, you can email myself or your math teacher or come to Hawk Lab.